Hello? Am I audible? Is it coming now? अब आ रहा है. Okay. I'll explain once again. Don't worry. Don't worry. Don't worry. I'll explain once again. You need not worry. Don't worry. Don't worry. I'll explain once again. From first slide onwards, I'll explain. Okay. Hydrology is very, very important course in GATE exam. Though it is a very small subject, but it has got decent weightage. So you'll get 2 to 3 questions accounting to 3 to 5 marks. Still noise is there? Noise is coming? Noise is coming. Is there any noise? AE, JE course also it is useful. Every course it is useful. In everywhere it is there. AE, JE students also they can attend. Everywhere they will ask questions. Okay, not only GATE. If you prepare for GATE, any exam you can write. So that is the mantra. Competitive exams only one time honestly you need to prepare. Once you prepare honestly, every exam you can write. World of shorts. No noise now. Okay. So the very purpose of this course is to estimate water yield from a drainage basin or a catchment. So what is a catchment? See now. So if you join a college, students from different parts of a city, they join at one place. So the total city is a catchment for the classroom. Exactly for same way, similar way, for every water resource, there is a catchment. So a resource catch water from certain area in the nearby surroundings. The area from which it collect water to a particular source is called a catchment for that source. So the very purpose of hydrology is how much water that source collect from a catchment. So this we try to work out by performing hydrological analysis. Clear now? So for this purpose what we do is we treat catchment as a hydrologic system. So system receive certain inputs, system produce certain output. That catchment is treated as a hydrologic system. So this catchment receive input in the form of precipitation and catchment produce output in the form of runoff. Clear now? So in between what is there? Straight away runoff cannot be measured. Precipitation you can measure in a catchment, but you can't measure runoff coming out of the catchment because catchments are very big. You can't measure it out. So therefore, to work out that runoff component from a catchment, we force it to work out other parameters indirectly. Precipitation we work out evaporation, we work out transpiration, we work out evapotranspiration, we work out infiltration. All of the catchment losses also taken into account. So that we can finally work out runoff component. Runoff is the only component which cannot be measured. So remaining all components that we can measure, they are measurable. Precipitation you can measure, evaporation you can measure, transpiration you can measure, evapotranspiration you can measure. The only runoff component, there is no device to measure runoff component. Therefore, we need to analyze and find out. For that purpose, we perform hydrological analysis. Okay. So what parameters we need to analyze? There are certain parameters. So what are the parameters? Precipitation, evaporation, transpiration, evapotranspiration, infiltration, runoff. Precipitation is an input. Evaporation, transpiration, evapotranspiration, infiltration, all are catchment losses. Finally, runoff is an output. Finally, see now, why you are taking class now? We are giving inputs to you. It's an education system. In education system, students receive certain inputs from a teacher. So all of the inputs you can't remember. Certain things you can remember, certain things you forget also. So finally in the exam, how much amount of output you produce. So that is important. That will give you success. Exactly. Finally, you are looking for output only. You want to get a good rank. You want to get a good score in the exam. Isn't it? So keeping that in your mind, you work out how much amount of inputs I need to take, and what sources I need to take, where I need to join, where from which book I need to read, what depth I need to read. So this and all you analyze and accordingly work out, isn't it? According to your result, what exactly you are expecting. I want to get all India #1 rank. So you are supposed to have good knowledge regarding the subject. So good books you have to study, from good teacher you have to learn the subject, right? So exactly like that. There are various methods to gain knowledge. So this and all we work out. How long I need to study, what depth I need to study, right? How many mock exams I need to take. So this and all, that will give you finally ultimately reach your destination. Exactly same way. Here, input is known to you, output you have to work out. So there, based on output, we adjust our input. Here, based on input, we work out output. Understood? Based on what exactly I am looking for. I want to get a #1 rank in GATE exam. Then how much amount of effort I need to put. Effort I need to put is my input. That effort I decide based on my output. What output I am exactly expecting. But here, unfortunately, it is nature. Because water is not a factory made product. It is a natural resource which is plentifully available in nature. How much nature gives to you? How much we can collect from the nature effectively. Isn't it? That's what we try to work out by performing hydrological analysis. Is it clear now? Any noise is there? Any disturbance is there? Come on, you comment there. Okay then. So towards working out that output, so we force it to assess the precipitation. All these parameters are measurable. You can measure all these parameters. Measurable parameters. By using certain devices, you can measure. This cannot measure. This is only estimated. So this is not measurable. Runoff cannot be measured. It only worked out, estimated, not measurable. So that is the reason why this subject. If runoff also we could able to measure, there is no such subject called hydrology. Hydrology is not required. Straight away you can measure it. Why you need to work out all these things? Not required. Runoff is the only component which is not measurable. Okay? This is not measurable, but all these parameters are measurable parameters. That's what we try to do in hydrology course. So towards working out that, the first topic is precipitation. Understood now? You are asking class length, okay? Just now started asking class length. Classes go only 1.5 hours, 2 hours, not more than that. Okay? So I'll teach this subject for 1 week. So maybe some 20 hours, not more than that. Don't worry. So precipitation. Precipitation, all forms of moisture that reach the ground from atmosphere is known as precipitation. So all forms of water, all forms of moisture that reach ground from atmosphere is known as precipitation. Okay? So we receive this precipitation in different forms at different places. In India, we receive most of the precipitation in the form of rainfall. Elsewhere in the world, it is in the form of snowfall. See now, if you see the Europe and America, North America, it is experiencing severe winter storm. What is that storm? That is not a rain, that is a snowfall. So all forms of moisture that reach ground from atmosphere is known as precipitation. Precipitation is a general word. Specifically in India, whenever we talk about precipitation, by default it is rainfall. So what are the forms of precipitation? What are the different forms of precipitation? So precipitation could be in the form of rainfall. Precipitation could be in the form of drizzle. Precipitation could be in the form of snowfall. Precipitation could be in the form of sleet. Precipitation could be in the form of hail. Okay? All is different forms of precipitation. Different parts of the world we receive different types of forms of precipitation. So when can you call precipitation is a rain or rainfall? Precipitation in the form of water droplet of size. So it is in the form of water droplet of size greater than 0.5 mm and intensity. Intensity means rate at which it rain. Rate of rainfall. Intensity is greater than 1 mm per hour, then it is known as rain or rainfall. Okay? In the form of water droplet of size 0.5 mm, greater than 0.5 mm, and intensity greater than 1 mm per hour, then it's called rain or rainfall. So depending upon intensity, rains are classified into 3 categories based on I. Rains are classified into, this question also they are asking in competitive exam. 1. Light rain, moderate rains, and heavy rain. Light rain, moderate rain, and heavy rain. Sometimes in newspapers and all they write light rain has occurred in Delhi. Heavy rain lashed out in somewhere in Bangalore. Heavy rain has occurred in Kolkata. Something like that. They keep on announcing in news channels now. What is that? When can you say that it is a light rain? When can you say that it is a heavy rain? So precipitation in the form of light rain. When can you say that it is a light rain? When intensity of rainfall is between 1 mm per hour to 2.5 mm per hour. It is called light rain. When intensity is between 2.5 mm per hour to 7.5 mm per hour, it is called moderate rain. When intensity of rainfall is greater than 7.5 mm per hour, then it is called heavy rain. So based on intensity, we can classify these rains into 3 categories. This question also they are asking in competitive exams. Light rain, moderate rain, heavy rain. I value between 1 mm to 2.5, light rain, 2.5 to 7.5, moderate rain, more than 7.5, heavy rain. Okay, that's it. This much idea is there, more than sufficient to answer questions in competitive exams. You need not go deep inside that. Then snow, second one is drizzle. Drizzle also same as rain only. So precipitation in the form of water droplet of size exactly opposite. Less than 0.5 mm, intensity less than 1 mm per hour is known as drizzle. Drizzle is very low intensity rain. It is very low intensity rain. Very low intensity rains are called drizzle or drizzling. So it is water droplet of size less than 0.5 mm and intensity less than 1 mm per hour. It is known as drizzle. So whenever it drizzle for long period. Whenever it rains occur for short period. In short period only, because intensity is nothing but, right? It is dP by dt. What amount of rain has occurred in a given time. So precipitation in a given time is called intensity or rainfall. Rainfall in a given time. Otherwise, people can take it as, you can write it as P by T. P by T stands for what? Rainfall in a given time. Rainfall by time is equal to intensity. So when I value, when it is low, when time duration, time at which it occurs is very high, intensities are very, very low. So when rains occur for short period, then I value will be very, very high. When rains occur for long period, I value will be very, very low. Understood? So for long duration storms, I value will be very, very low. Understood now? So I is nothing but rainfall in a given time. Okay. Next, third one is snow or snowfall. Snowfall. Precipitation in the form of fine ice crystals of size less than 1 mm. So it is fine ice crystals of size less than or equal to 1 mm. It is known as snow or snowfall. Less than 1 mm snowfall. Sleet means same ice crystals of size 1 mm to 5 mm. 1 mm to 5 mm are known as sleet. Sleet normally occur in Europe. It is also precipitation in the form of ice crystals of size 1 mm to 5 mm. It's called sleet. Then hail means precipitation in the form of, right, irregular sized ice crystals of size, large lump of ice crystals of size, large lump of ice crystals, of size greater than 8 mm, irregular sized or irregular shaped ice crystals of size greater than 8 mm is called hail. Hail is nothing but it will have very high intensity snowfall. It is. Snowfall occur with large size ice crystals, irregular sized pellets of ice dropped down from the atmosphere. It is now happening in Europe, North America. They are experiencing. So for the past 3 weeks, they are experiencing severe hail somewhere in North America. Okay. So different places in India, precipitation means by default, it is in India. Whenever we talk about precipitation is only in the form of, precipitation means by default it is rainfall, and very few parts. So 90% of precipitation in the form of rainfall. In extreme north India, not 90%, 95% of rainfall is only, precipitation is in the form of rainfall. Only extreme north India, some places we receive snowfall as well. So 5% of the places in extreme north India, Jammu Kashmir, Himachal Pradesh, right, Arunachal Pradesh, extreme north India, some places we also receive snowfall. 95% of the rainfall in India is, 95% of precipitation is only in the form of rainfall. So therefore, whenever we talk about precipitation, by default it is rainfall in India. Understood? So we did not mention about that. Whenever we talk about precipitation, by default it is rainfall. Is it okay for you? Okay, that's all. So related to this precipitation, so normally we measure precipitation in the form of, by using devices known as, actual measurement is, first question is related to measurement of precipitation. Precipitation is measured as a vertical depth of water that would accumulate on a level ground. So a level ground is prepared. If level ground, if receive a rainfall, right, if it receive a precipitation in the form of rainfall, of course in India by default it is rainfall, then what amount of water accumulate on a level ground, that is taken as precipitation of that area, precipitation of that place, precipitation of that catchment or something like that. So this is called, we denote it by P. So depth of water accumulate on a level ground. If all precipitation is retained where it fell, suppose we denote it by P. Precipitation is denoted by P, depth of water accumulated on level ground. But is it possible? So before we go there to measure out, midnight rain occur, early morning we go there to measure. Before we go there, some water soak into ground, some water evaporates, some water flow laterally in all directions. No more water retained there. So it is impossible to retain all the precipitation that fell on the ground. So therefore, we use some kind of devices. Principle is this. So precipitation is measured as a depth of water accumulated on a level ground. Okay? But it's not possible. Therefore, precipitation is measured by devices known as rain gauges. So it is practically not possible. Measured by devices known as rain gauges, rain gauges. Some people call gauze also. Okay? Yeah, I'm going speed only, sir. Don't worry, sir. Rajkumar. So we have got different types of rain gauges. So there are some rain gauges. So rain gauges, if you install, then what happens on a level ground? So they collect rainwater and hold that rainwater, so without allowing any water to go away from the place of collection. Therefore, comfortably we can measure it. What depth of water accumulate on a level ground. So types of rain gauges. We have got two types of rain gauges. One is recording type rain gauges. Just know the names of the rain gauges, more than sufficient. You need not know their features and all, not required. We have got non-recording type rain gauges. Non-recording type rain gauges. Okay. So among non-recording type rain gauges, the popular one in India is Siemens IS rain gauge. One is Siemens rain gauge. This Siemens rain gauge is universal, but whereas Siemens rain gauge, some places in India that may not accommodate all the rainwater, because many places in India heavily they receive rainfall. Therefore, it doesn't have it doesn't have enough capacity to hold all the rainwater. Therefore, to suit our needs and requirements, we have developed IS rain gauge, Indian Standard Rain Gauge. Of course, it is some improvements made to Siemens rain gauge to suit Indian conditions. So this is popular in India. So Siemens rain gauge, IS rain gauge. Any kind of non-recording type rain gauge, it collects. It has got a bottle to collect rain, to hold rainwater. To collect rainwater, it has got a collector provided with one funnel connected to collector, which deliver water into a bottle. So this arrangement is fixed permanently to ground. The detailing and all not required. The non-recording type rain gauges only measure 24 hours rainfall. So they can't give you complete history of the rain. In the 24 hours, how much amount of rain has occurred. Only measure rainfall in 24 hours. Because there is one separate department to measure these weather parameters. It's called meteorological department. So that people from meteorological department, every day they measure rainfall at exactly 8:30 a.m. early morning 8:30 a.m. Yesterday 8:30 to today 8:30 a.m. What amount of rain has collected by the gauge, that is recorded as today's rainfall. Today 8:30 to tomorrow 8:30 is collected as whatever amount of water collected inside the gauge, that is recorded as tomorrow's rainfall, something like that. Only measure rainfall in 24 hours. We don't get complete history of the rain. Okay, 24 hours rainfall only you can measure. So no other details related to rain, or no other details related to rain, but they are less expensive. Okay, so to get more information regarding the rains, then we have to go for recording type rain gauges. Under certain circumstances, non-recording type rain gauges you cannot employ also. Then you force it to use recording type rain gauges. So the advantage of recording type rain gauges are, okay, here attendant is required. For non-recording type rain gauges, physical attendant is required. Recording type rain gauges, no need to go there to the gauge, and you can carry out measurement as per your comfort and convenient. Recording type rain gauges. We have got three popular recording type rain gauges. They are hello, is it okay? Any noise is coming or any disturbance? Is it telecasting properly? So recording type rain gauges, one is very popular, one is what do you know about these non-recording type rain gauges? Recording type rain gauges give complete history of the rain. In a 24 hours, how much amount of rain has occurred, what intensity it has rained, how many times it has rained, how long it has rained every time. Every detail related to rain we can collect. They give every detail related to rain. They record every detail related to rain. That's why they are called recording type rain gauges. They record every detail related to 24 hours rain. In 24 hours, how many times rain has occurred? 24 hours all throughout the day it doesn't happen. Rain occur 1 or 2 times in a day. Each time, how long it has occurred, what intensity has occurred, what is the depth of rainfall. Every detail we can collect. So the popular among them are weighing bucket type rain gauge. Weighing bucket type The unique feature of weighing bucket rain gauge is it measures both rainfall and as well as snowfall. That much idea is there, more than sufficient. So to measure exclusively rainfall and as well as snowfall, we recommend weighing bucket rain gauge. To measure rainfall and snowfall, we use weighing bucket type rain gauge. And tipping bucket type rain gauge, popularly used to measure rainfall at remote and inaccessible locations. So tipping bucket rain gauge to measure rainfall at remote places, where you cannot go every day to carry out the measurement, remote and inaccessible locations. See, now Himalayas, you want to measure rainfall. In mountain region, you want to measure rainfall. Thick forest, you want to measure rainfall. Every day you can't go there. In such case, we can use this tipping bucket type rain, inaccessible places. We use this. And third one is siphons rain gauge. Siphons rain gauge, which is also known as float type rain gauge. This rain gauge is normal conditions, we use this. Under normal circumstances, as per IS codal recommendation, no special condition is there to record rainfall data completely, then we use normally siphons rain. Whatever it may be, siphon rain gauge or tipping bucket or weighing bucket, we need rainfall data, that's it. The first type of numerical related to these rain gauges is, right? How many number of rain gauges to be installed? Catchments are very big. Catchments are very big. This is a catchment. It is spread in so many thousands of kilometers square area. Right? Very big. Only one rain gauge you install, that only one rain gauge you provide, it doesn't represent entire catchment. Then how many rain gauges to be installed to represent rainfall data over entire catchment? That's a question, isn't it? So just by, see now, most of the times you go to the coaching centers. When you go there, they'll show you number one ranker is from our coaching institute. Just by looking at the number one ranker, can you go blindly and join? That number one rank he may got because of his own hard work, not because of institute. Okay? But if you go to every institute nowadays, you will find same photograph. But where he exactly took coaching, that is important to you. Isn't it? That is important. So which coaching center delivering properly information? Which coaching center truly inspiring the students, delivering the true content without shouting, without yelling. See now nowadays what is happening everywhere? Shouting, yelling, right? It is like a drama. It is like a comedy show. Coaching online classes also like a comedy show only. Yelling, shouting, right? Which is not required for us. So I am not commenting them. That's their style of teaching. But anyway, what is important finally, ultimately, so we have to deliver the content. That is important. Exactly same way. How many rain gauges are required? So it's called optimum number of rain gauges. This is the first numerical question in precipitation. Optimum number of rain gauges. Optimum number means not the minimum gauges, not the maximum gauges, correct number of rain gauges. Rain gauges in a catchment. To find out optimum number of rain gauges in a catchment, so we require some data, rainfall data. So we install certain rain gauges based on IS codal recommendation. So when catchments are very big, we don't know how many number of rain gauges are required. Therefore, IS code has given certain recommendation. Following this recommendation, we install certain number of rain gauges. They work for some time. They record some rainfall data. That data we collect and we carefully analyze that data. From there, we try to arrive. The gauges installed in a catchment are right in number or wrong in number. If they are wrong in number, we don't hesitate to install few more rain gauges. If they are correct in number, it's okay, they are working well. So we are happy with that rainfall information. Okay. First, we need to verify whether rain gauges in a catchment are sufficient or deficient. If they are sufficient, well and good. If they are deficient, so we don't hesitate to recommend few more gauges to be installed to get the rainfall data with a given degree of accuracy. Because 100% accurately, in no system you can carry out the measurement. No system can give 100% accurate information. So certain amount of error is always allowed. But amount of error that allowed in measuring this rainfall information, that depends on purpose for which we use rainfall data. If this rainfall data is used for very important purpose, like design of multi-purpose dam across a river, then a high degree of accuracy is required, because we invest billions and billions of dollars. So we don't want to waste our money. In such case, so we require rainfall information with very high degree of accuracy. In such case, number of rain gauges required are different. Suppose you want to construct a culvert across a road. Culvert is not an important hydraulic system. Therefore, even less degree of accuracy, 60% accuracy also okay it is. So depending upon the purpose for which we use rainfall data, number of gauges we recommend. Optimum number depends. Okay. So this optimum number of rain gauges, to work out what we require, rainfall data recorded by the existing rain gauge stations. Suppose this is a catchment, let us assume. This is a catchment. This catchment already installed certain number of rain gauges. This is rain gauge station 1. This is rain gauge station 2. Like that, m number of rain gauges are installed in a catchment. Rain gauge station is a place where rain gauge is installed. The place where rain gauge is installed is called rain gauge station. Every rain gauge station you will find one rain gauge. So there are m number of rain gauge stations in a catchment. They record m number of rainfall data. So station 1 record rainfall data P1, station 2 record rainfall data P2, station 3 record rainfall data P3, station M record rainfall data PM. But none of these rainfall data recorded by these gauges represent entire catchment. This entire catchment is represented by single rainfall information known as P bar. This is mean rainfall of the entire catchment. To work it out, so we need to install certain proper number of rain gauges in a catchment, isn't it? So this represent complete catchment. So to get that rainfall information, correct number of rain gauges we need to install. We carefully analyze rainfall data recorded by existing rain gauge stations. We put that data to statistical analysis. Thereby, we can find out optimum number of rain gauges. So let P1 dot P2 dot PM be the rainfall data recorded by the existing rain gauges installed at rain gauge stations. These rain gauge stations we call them as RG station. Rain gauge stations 1, 2 dot m respectively. By subjecting this data to statistical analysis, optimum number of rain gauges are found. So, by subjecting this data to statistical analysis, the following parameters are analyzed. Following parameters: statistical, this data to statistical analysis, the following statistical parameters are found. So we work out these parameters. First one is mean of rainfall data. How to find mean of rainfall data recorded by the existing rain gauges? Mean of rainfall data P bar is equal to, it is P1 plus P2 plus dot PM by M. There are m number of rain gauge stations, m values are there, divided by m. Then we work out standard deviation of rainfall data. My profile is not required for you, Sarthak. My profile, why you need my profile? Either I am delivering content or not, that is important to you, Sarthak. Profiles and all, what you can do? Standard deviation of rainfall data. Mean of rainfall data P bar. Standard deviation of rainfall data, how to find out? It is sigma into Pi minus P bar whole square by M minus 1. Sigma Pi minus P bar whole square by M minus 1 will give standard deviation of rainfall data. Then for this, find coefficient of variation. Coefficient of variation of rainfall data. That's called CV. It is 100 sigma by P bar. So once you work out these three parameters, right, then you are in a position to work out optimum number of rain gauges, right? So first what you need to work out? P bar. So P1 plus P2 plus Pm by M. I am giving information, equations. These equations only you have to remember. Then standard deviation is equal to root of sigma Pi minus P bar whole square. That means P1 minus P bar whole square. P2 minus P plus P2 minus P bar whole square plus P3 minus P bar whole square, like that. M number of rainfall values you need to work out. M minus 1. This is standard deviation. Once you get these two, then you can find out CV. CV is equal to 100 sigma by P bar. So once you get, then you can find out optimum number of rain gauges. Optimum number of rain gauges required. Optimum number of rain gauges required. What is that? N to estimate the mean rainfall, or to measure the, or to estimate the mean rainfall. With an allowable or admissible percentage error, E. Some amount of error is always allowed, so error should not be more. Depends on the purpose for which. Admissible percentage error, E. Right? Optimum number of rain gauges, N is equal to, come on now, N is equal to CV by E whole square. Ultimately we will get this. What is E? Error allowed in measuring the mean rainfall. E is equal to error. Error depends on what? Accuracy. Accuracy, percentage accuracy is equal to 100 minus E. So purpose for which we use data. More accurate data is required, less error is allowed. So N value inversely proportional to E, and E value inversely proportional to accuracy. Accuracy is more means error allowed is less. Accuracy more means error allowed is less. Error allowed is less, number required is more. Accuracy less, accuracy is sufficient, then error allowed is more. Okay? Less accuracy, more error is allowed. More error allowed, less number also sufficient. So it all depends on purpose for which we use rainfall data. So more accurate rainfall information is required, more number of rain gauges. So N is straightaway proportional to accuracy. More accuracy, more number required. Less accuracy, less number required. Straight link is not there, indirect link is there. So once we get N value, optimum number, then we are in a position to comment whether the rain gauges already working in a catchment are sufficient in number or deficient in number. Okay? So let us see. So after this, then we come to know that conclusions. Sometimes this conclusion is also important, right? If the N value we get, that is greater than M value, that what does it indicate? What does it indicate? There is a deficiency of rain gauges. There is a deficiency of rain gauges in a catchment. Deficiency of rain gauges. Then we recommend additional number of rain gauges. Then additional number of rain gauges recommended is equal to, whenever deficiency is there, additional rain gauges we recommend. Rain gauges recommended to measure that rainfall accurately is equal to, it is N minus M. If N is greater than, less than or equal to M, sufficient number of rain gauges working. Sufficient number of rain gauges working in a catchment. So we are getting rainfall data with the desired degree of accuracy. So therefore, no recommendation. So no additional gauges are required. We don't require any additional gauges. No additional rain gauges required. So finally, we have to conclude like this. Understood now? This much idea is there. You can answer any question in any exam. That's it. Shall we take up now problems? Shall we go ahead with problems? Okay. Let us see few competitive exam questions. Then you realize how important this topic is. Sometimes simple questions they will ask, sometimes they will give you complex questions also. Example, for example, all these are competitive exam questions only. In a catchment, there are 6 rain gauges, 6 rain gauge stations. Each rain gauge station has got 1 gauge. With average depth of rainfall (92.8 centimeter) and standard deviation of rainfall values recorded in these rain gauge stations is 30.7 centimeter. So for a 10% degree of error in measurement of mean rainfall, the optimum number of stations required. This straight question, nothing is there. Without calculator also you can manage. Optimum number of stations required is, come on, answer. So options given are 5 numbers, 6 numbers, 10 numbers, 11 numbers. Come on, work out. Let me see how many of you work out. Come on, fast. So what is given to you? One is given as average depth of rainfall, means P bar is given. The other one is standard deviation is given. E is given. So we require 3 data only. So solution to this question is so P bar is given. What is P bar? 92.8 centimeter. Standard deviation is given as 30.7 centimeter. And E is given as 10%. And you have been asked to find out optimum number N. Come on, work out. So what you have to work out? Only CV you have to work out. CV is equal to 100 sigma by P bar. So 100 into 30.7 by 92.8. Come on, what is this value? So 100 into 30.7 by 92.8. So it is 33.01. It is worked out in percentage. CV will get in percentage. Therefore, optimum number is equal to CV by E whole square. E also in percentage, CV also in percentage, percentage cancel out. So we'll get number only. Come on, work out. Answer by 10%. Whole square. So you got 10.94. Even you get 10.09, we round it to 11 only. Next highest number. Next highest number is 11. Always round it to next highest value. So don't go with the 10 number. If you round it to 10 number, what happens? Error will increase. Increase in error is not allowed. Decrease in, instead 10.94 exactly give 10% error. 11 you provide, error will be less than 10%. That is okay. You are expected to get 90% accuracy, but you are getting 91% accuracy, 92% accuracy by adjusting the error to next highest value. By adjusting the number to next highest value. Don't adjust to next lower value. Higher value adjust. Error decrease in error is allowed, but increase in error is not allowed. Understood now? Hope this point is clear to you. Not 10 sir, that's what I am saying. 10.94 you got, round it to 11. Sarthak, for you only I am teaching this. Okay then, let us see one more question. Example 2. In a catchment there are 5 rain gauge stations. You can also copy. With a coefficient of variation. He has given that value with a coefficient of variation of 33%. Then the percentage accuracy of the existing network, rain gauge network, in the estimation of average depth of rainfall. Come on, work out. Basin means catchment only. In the basin is. So options given are 14.76%. Option B is 85.24%. Option C is 10%. Option D is 67.36%. Come on, work out. What have been asked to find out? Accuracy. So to find out accuracy, what is required? Error is required. So what is given to you? 5 rain gauge stations. So M is given as 5. Okay. CV value is given as 33%. The existing rain gauge network, percentage accuracy of measuring rainfall. So what to do? Assume N is equal to M. Then only you can solve, right? Then N is equal to CV by E whole square. So from this you can find out for 5 rain gauges what is error you can calculate. So error is equal to for 5 rain gauges. So it is 33 square by 25. 33. Okay, error no, this we want. So root 5 this is. Root 5 by 33 by root 5. It is 14.758 rounded to 14.76%. Therefore, accuracy, percentage accuracy is equal to, it is 100 minus percentage error. So 100 minus 14.76. minus 100. So it is 85.24. 85.24% is the accuracy with which we are getting the answer. So B is the correct option. Like that you have to answer. Clear now? Very good, very good. Error is 14.75. Accuracy is asking. He is asking what? Accuracy. What is percentage accuracy? Okay? That's it. Let us see one more question. So this is so far so good, no? I'll give you how to work out this P bar and all. Let me see how many of you work out. This question is a tough question. This kind of questions only they will ask in GATE exam. Example 3. There are 3 rain gauge stations in a catchment. Recorded 2 centimeters, 3 centimeters and 4 centimeter rainfall respectively. Find how many number of additional rain gauges required. You work out this problem, then I understand that you got the concept. Additional rain gauges required to measure mean rainfall with an allowable error 0.5 centimeter. Sorry, 0.1 centimeter. I'll give only small amount of error. Come on, work out now. Not 0.1 centimeter, okay. Then allowable error. Point 0.3 centimeter, okay. That's better. We'll get round figures. Okay, come on, work out. You take 0.3 and work out because you'll get round figures. Fractions you don't get. Come on. So what is given to you? I'll help you. So he has given P1 is equal to 2 centimeter, P2 is equal to 3 centimeter, P3 is equal to 4 centimeter. For this we need to find out what? P bar, standard deviation, then coefficient of variation, then optimum number, then additional number. How to find additional number? N minus M. What is asking? N minus M. This you have to work out. Until you know N, what is M? M is equal to, already M is known. M is equal to 3 stations. 3 stations are there, no? M is equal to 3. N value to find out. If is no, N is known, M you can work out. So I have given hint to you, then find out. Come on fast. Calculator also not required. Without calculator you can manage. I'm not asking P bar, man. I'm asking how many number of additional rain gauges. Answer I need. So let me try, okay? Let me help you. So what is P bar? P1 plus, P2 plus, P3 by 3. So 2 plus, 3 plus, 4 by 3. 9 by 3, it is 3 centimeter. What is standard deviation? Root of sigma Pi minus P bar whole square by M minus 1. So how to write this? It is 2 minus 3 whole square plus 3 minus 3 whole square plus 4 minus 3 whole square by M minus 1. M is equal to 3. So 3 minus 1. So 2 minus 3 is minus 1 square, 1 only. This is 0. This is 1. 1 plus 1, 2. 2 by 2. 2 by 2, 1. Root 1 is equal to 1 centimeter only. Standard deviation also 1 centimeter. Then CV is equal to 100 sigma by P bar. So 100 into 1 by 3. So it is 33.33%. 100 by 3. CV also we got. Therefore N is equal to, so it is CV by E whole square. But E is not given. Percentage error is not given. Amount of error is given. How to find out percentage error? Therefore, percentage error E is equal to, it is amount of error allowed by P bar. So amount of error allowed is how much? 0.3 centimeter. P bar is 3 centimeter into 100, of course. So into 100. So it is 10%. So we got a percentage error also. Next, you can get optimum number. So optimum number is equal to, so it is CV by E whole square. It is 33.33% by 10% whole square. It is 9 point something you will get. You can round it to 10. But question is, how many number of additional rain gauges required? So additional rain gauges required is equal to 33.33 by, of course, GATE exam calculator is allowed, you can use it. Sometimes in ESE exam calculator is not allowed. Then also, 11 point someone it, this is 11 point something. So 11.1 we got. .1. So 11.1 you can't provide, so we'll provide 12. So additional rain gauges required is equal to, additional number of rain gauges required is equal to, how many additional gauges required? 12 minus 3, 9. 9 is the answer, not the 12. Because he is asking additional number of rain gauges. So n minus m. So it is 12 minus 3. So it is 9. Existing number is 3 only. So the answer is 9. 9 is the answer. Anybody got 9 answer? Rajkumar, you are wrong, Rajkumar. 7. I am sorry, Rajkumar. Very good, very good, very good. Good. So this is how you can work out. This is the first type of question. I solved one tough question, I solved one easy question, I solved one moderate question also. Sufficient for you. The quick revision class. Next, second topic is, second numerical part related to precipitation is, understood this one? You want to check out? Once again you check out. So M is known to you already, existing rain gauge stations. M is known. Therefore, N value you have to find out. So once you get N value, additional number of rain gauges you can work out. Remaining people are not responding. You have to respond. Response should be there from both sides. See now my audio is not working, then everybody responded, then I corrected it. Exactly. When you respond, if you go wrong, then I will correct you. If I go wrong, you can correct me. I am not saying that I am always correct. Right? Even sometimes teachers also go wrong. So both sides we should communicate. Okay. So second type of problem is estimation of missing rainfall data. This is also a very popular question in GATE exam. Estimation of the missing rainfall. Let us assume it has a Px. So to perform this hydrological analysis, what you require is the continuous rainfall record is required. Anywhere rainfall record is broken, there is no continuity or discontinuity is there in rainfall information, we find very difficult to use that data in the analysis. Therefore, we badly need continuous record. But unfortunately, gauges also, like human beings, sometimes they malfunction. Due to obvious reasons, they don't record rainfall data. So if that is the case, because of that broken information, we no more use that data. So we no more use that rainfall data. In that case, right, it is very difficult to use that rainfall data in our analysis. But there is no option left with you because we have got only that. So therefore, what we do, we apply small correction and we estimate that missing rainfall information by using some mathematical method. We work out that missing data. Wherever gap is there, that gap we try to fill so that we can generate a continuous record. So that that record can be used in hydrological analysis. Understood now? What is the purpose of estimating missing rainfall data? So it requires continuous rainfall record. Without any broken rainfall data. To use data in analysis. Okay? Whatsoever may be the reason is, if rainfall data is missing, that missing rainfall data we estimate by one procedure. That procedure you have to learn. So whatsoever may be the reason. If broken rainfall record is there, then that missing rainfall data estimated by following procedure. I have given little concept followed by numerical procedure. Concept also important. Blindly you cannot learn the subject, okay? We need continuous rainfall record to use that data in the analysis. But rain gauge also like human beings, right? You all will not attend all of my sessions. Some of you miss the session. Then all of a sudden, after 2 days you watch my session, then what happens? I will be teaching infiltration or I will be teaching some hydrograph. Then you will be confused because the past information, rainfall data also we use there. Then I may be talking something about rainfall, you may get confused. So we don't remain in that confusion forever. We try to fill that gap. So by retrospecting, by taking your friend's help or you are taking some books or something like that you read, we try to fill that gap. Exactly same way here also. So missing rainfall data of rain gauge station X we estimate by the following equation. Okay. So this is, there are m number of rain gauge stations installed in a catchment. This is rain gauge station 1, this is rain gauge station 2, this is rain gauge station X, this is rain gauge station M. So all these rain gauge stations, they are recording rainfall data. Station 1 record P1 data, Station 2 record P2 data, Station X record PX data, Station M record PM data. So unfortunately, when all the other stations recorded rainfall data, Station X was missed in recording the rainfall data due to some obvious reasons. So missing rainfall data at rain gauge station X, we have to work out. To work out that missing rainfall data at rain gauge station X, so we require two data. The rainfall recorded by other rain gauge stations during the same time period, where station X was missed in recording rainfall data. We also record normal annual rainfall data of all adjacent rain gauge stations to station X. The normal annual rainfall data is denoted by N values. So N values record normal annual rainfall data of all rain gauge stations including station X. So 20 years, latest 20 years average annual rainfall data is known as normal annual rainfall data. So to estimate missing rainfall data at rain gauge station X, Px, it require rainfall recorded by the adjacent rain gauge stations. Adjacent rain gauge stations to rain gauge station X. That is P1, P2, Pm, and normal annual rainfall values of all rain gauge stations. All rain gauge stations including station X. That is N1, N2, Nx, Nm. So this is also given to you. So normal annual rainfall data is given. This data also given. Normal annual rainfall data means latest 20 years average annual rainfall is known as latest 30 years. Latest 30 years average annual rainfall is known as normal annual rainfall. Latest 30 years average annual rainfall is known as 30 years, not 20. Average annual rainfall is known as normal annual rainfall. Remember, this is also popular question in ESE exam. Then missing rainfall at rain gauge station X is estimated by normal ratio method. Then missing rainfall record at rain gauge station X, Px, estimated by normal ratio method. One more method here, simple average method, that is not been used mostly. This is only popular. So this Px is equal to, it is Nx by M into P1 by N1 plus P2 by N2 Pm by Nm. So this is the rainfall data recorded by adjacent rain gauge stations. This is the rainfall data recorded by station X. So adjacent rain gauge station data always taken inside the bracket. Station X data is taken left hand side of this one equation. Okay. That's all. So you have to remember only this equation. This is very popular question in GATE exam. So many number of times in GATE exam. So questions have been asked from this topic. Questions had been asked from this topic. Come on, work out. Let us see some few numericals related to this. Where M is equal to not the adjacent rain gauge stations. M is equal to number of adjacent rain gauge stations to station X. Not existing rain gauge stations. Adjacent rain gauge stations. Number of adjacent rain gauge station to rain gauge station X. That's all. Station X was missed in recording rainfall data. That data to find out. For that purpose, you require P data, N data. N data is normal annual rainfall record. P data is rainfall record recorded by the existing rain gauge station during the period Station X was missed in recording the rainfall data. Okay, that's it. This much idea is there. You can work out. Now let us work out few numericals. Let us just try one example. Example 4 it is. Let us try this question. The normal annual rainfall at rain gauge stations A, B and C are 170.6, 180.3, and 165.3 centimeter respectively. In 1987, Station B was inoperative and stations A and C recorded annual precipitations of 153 and 145 centimeters respectively. The annual rainfall at rain gauge station B in that year could be estimated as dash centimeter. Come on, work out. Just formula substitution. Of course, I have got a collection of questions from different competitive exams. So from there I am taking these questions. Come on. What to do? You have to remember that formula only. So, station B was inoperative, where station A and C are recorded as, how much recorded? That is P data, 153, 145 centimeters. Normal annual rainfall at all stations are given, NA, NB, NC. Right? Station B was inoperative. Remaining stations were working. Okay, I will put here station A, B, C. This is missing. This you have to find out. Remaining stations NA, NB, NC values are given. Normal annual rainfall data also given to you. So the normal annual rainfall data for 3 stations are given as respectively 170.6, 180.3, 170.6 centimeter, 180.3 centimeters, then 165.3 centimeters. That's all. You have been asked to find out PB. So PB is equal to, so adjacent rain gauge stations are how many? Only 2. So it is NB by M into PA by NA plus PC by NC. Adjacent rain gauge station data I have to take inside. NB value is 180.3 by 2, PA by NA. So 153 by 170.6 and 145 by 165.3. So that was the missing rainfall approximately, not exactly. Retrieval, going back and working out is impossible, but approximately you can guess. So 153 by 170.6 plus 145 by 165.3 into 180.3. Number of adjacent rain gauge stations are 2 only. So 2. It is 159.92 centimeter. Approximately it is, answer is given as 160 centimeter. Anybody has got 160 centimeter answer? 160 is correct. 159.92 is correct. Covin is right. Jellari, you are wrong. 162 you got. 160 option also there. That's how they put traps to you. So even if you go wrong also, there is one answer matching with your wrong thinking. Okay. Now let us clear this question. Let us try one more question. GATE question, let us try. This is asked in GATE 2015. A good question. In a catchment, there are 4 rain gauge stations. P, Q, R and S. Normal annual precipitation values are values at these stations are, it is given 780 mm, 1 sorry, 780 mm, 850 mm, 920 mm and 980 mm respectively. You can ask me, I can type, I can cut and paste here, but if you write, then only you can fill the question. If you cut and paste and read, you don't get any idea. That's the reason why I am writing here. In the year 2013, stations Q and R and S, Q, R and S are operative but P was not. Using the normal ratio method, of course, this is only popular. Another method is simple mean method that we don't use. Because to use that method, it has to satisfy condition that is impossible to satisfy that condition. So, using the normal ratio method, the precipitation at station P, the precipitation at station P for the year 2013 has been estimated as 860 mm. Clearly read question. Okay. So if the observed precipitations, if the observed precipitations at stations Q and R for the year 2013 were 930 mm and 1010 mm respectively. What was the observed precipitation in mm at station S? This is 2 marks question for that year. That was the question. Come on, work out. GATE 2015 question. So what is given is, right, there are 4 rain gauge stations P, Q, R, S. So station S, station P was not recorded rainfall data, where Q, R, S are recorded. When station P was not recorded, Q, R, S were recorded. P, Q, P, R, P, S. Precipitation at Q, precipitation at R, precipitation at were recorded as a normal annual rainfall also given to you. And this is not recorded but estimated by normal ratio method, and it was found as, right, how much they found? How much they found? Using the normal ratio method, the precipitation station P for the year 2000 has been estimated as 860 mm. So they found it as 860 mm. By normal ratio method, they estimated it as 860 mm at station P. So they have measured it, they have estimated and found it as 860 mm. Then during that period, the observed precipitation values at remaining stations were 930, 1010 mm at Q and R. At Q and R, 930, this is 930 mm and this is 1010 mm. And what was the observed precipitation at station S? This you have to work out. Okay, actually this was missing and it was found by normal ratio method. And normal annual rainfall values of all these stations are given to you. NP, NQ, NR, NS. So they are given as NP, NQ, NR, NS. They are given as 780, 850, 920, 980. 780, 850 mm, 920 mm and 980 mm respectively. This is given. So what is missing rainfall data? Actually missing rainfall data at P only. So if missing rainfall data to get at P 860 mm, what should be the observed rainfall data at station S? So what is the missing rainfall data? Can you tell me now how to write that equation? How to write that equation? Come on. How to write that equation? So missing rainfall data is not there at station P. It was there. Actual equation is this PP is equal to, it is NP by M into PQ by NQ plus PR by NR plus PS by NS. Q, R, S are working, PP was not working. So what is this? Observed rainfall data of adjacent rain gauge stations. Adjacent rain gauge stations. This is missing rainfall data. So still missing rainfall data is at station P only. If you write like this, if you assume that PS is missing, and if you write like this, you will go wrong. This is not correct. PP by NP, like this if you take equation assuming that PS is missing, then you will go wrong. PQ by NQ plus PR by NR if you take, then you will go wrong. This is right, wrong, this is right. So this is not missing, this is observed. But unfortunately this was not given. So observed data always you suppose take here, missing data you should get, you will bring here. So this is how you need to write that equation. If you write like this, you will go wrong. Understood now? Why this question is given? Because some students take like this also. They take it as missing rainfall data at station S. Station S was missing, they think like that. That is wrong. Missing rainfall data still it is PP only, but it was estimated 860. To get that 860, what should be the observed rainfall data at station S? This S value or find out. Any one unknown in that equation you can work out. One equation, one unknown. It could be missing rainfall data or it could be observed rainfall data. Or observed rainfall data is given, it should be even normal annual rainfall data also you can work out. Any one unknown you can work out in that equation. Understood now? So now let us substitute. So if we substitute what is 860, we got missing rainfall data at station P was 860 mm, right? So therefore 860 is equal to, it is PP by NP by M. Observed rainfall number of stations adjacent is 3. So M is equal to 3. Okay? So inside bracket 3 stations are there, M is equal to 3. Inside bracket 2 are there, M is equal to 2. Inside bracket 4 are there, M is equal to 4. So 860 into NP by 3, 780 by 3 into, it is PQ by NQ. So PQ by NQ, 930 by 850. So 930 by 850 plus 1010 by 920. 1010 by 920 plus, this is missing, PS by NS. NS is given, 980. So what should be the observed rainfall data at PS so that we get missing rainfall data at station X as 860 mm. That was the question. So therefore PS is equal to, come on find out. Calculator is allowed, you can use calculator, no issue. So it is 1093.43 I got. So what is your answer? I got 1093.43 mm. How much you got? Come on, type there. Simplify and find out, work out. Okay? Understood? Any doubt is there regarding this question? You can ask me. So this is how we can work out missing rainfall data if at all you require to find out. So let us take one more question. This is ESE question. This asked in ESE exam. Example 6. ESE question we can manage without calculator also. In a watershed also same as catchment only. 4 rain gauges. Rain gauges, whatever it may be. 1, 2, 3 and 4 are installed. The depths of normal annual rainfall at these stations are 60, 75, 80 and 100 centimeter respectively. The rain gauge at station 3 went out of order during a particular year. The annual rainfall for that year recorded remaining stations. Remaining 3 stations. Were 90, 60 and 70 centimeter respectively. The rainfall at station 3 can be considered as options given are 60 centimeter, 70 centimeter, 80 centimeter, 120 centimeter. This is given in ESE exam, ESE 2002. Without calculator you can manage. So what is given? There are 4 rain gauge stations. 1, 2, 3, 4. What is given? Station 3 was inoperative. Remaining 3 stations are working. So P3 was missing, whereas P1, P2 and P4 are given. So P1, P2, P4 are 90, 60 and 70 centimeter respectively. And normal annual rainfall for all these stations also given to you, N3 and N4. So normal annual rainfall for all these stations are given as 60, 75, 80, 100. 60, 75, 80 and 100 centimeter respectively. What is missing rainfall data at station 3? Come on, work out. Without calculator you can manage. Comfortably you can manage without calculator. So direct substitution in the formula. So P3 is equal to, it is N3 by M into P1 by N1 plus P2 by N2 plus P4 by N4. That's all. So N3 is given as 80 centimeter. So number of percent rain gauge stations are 3. Inside bracket 3 are there. So 80 by 3, P1 by N1, 90 by 60. 90 by 60, 1.5. Without calculator you can manage. 75 by 6, 60 by 75. 60 by 75 is 0.8. Then 70 by 100, 0.7. So it is 80 by 3. Without calculator also you can manage. 1.5 plus 0.8 plus 0.7. So it is 80 by 3 into 3. So 3 get cancelled. You left with 80 centimeter. So that's how you have to manage without calculator in ESE exam. So 80 centimeter is the answer. That was the answer for that question. You have to tick mark what? 80. That was the answer for that question. Clear now? So today we covered 2 models. Today class is 4:30 to 6:30 every day, 2 hours. Tomorrow onwards I will take morning 1 session and afternoon 1 session I will take. So tomorrow I will take 11 o'clock to 1 o'clock, again 4 o'clock to 6 o'clock. So I will try to complete as fast as I can. So today I will stop here. First class 4:30 to 6:30 is my scheduled time. So before I conclude, I will remind you once again, from tomorrow onwards every day I will take 2 sessions. One is 11 a.m. to 1 p.m. first session. Again I will take 4 p.m. to 6 p.m. second session. So we will try to complete as fast as we can by Saturday maximum. If not Saturday, by Monday, next Monday. We will complete the, then once we complete this, then I can take geotechnical engineering fast mode. Do attend and bring your friends also. Maybe it is useful. Anyway, free of cost. Avail, make use of this. Avail this opportunity and enjoy the revision. Already if you know, well and good, then also it is useful to you. So Unacademy is offering 23% discount. Okay. I will teach you little theory to solve the questions, because it is GATE oriented program. So straight away GATE is more of numerical oriented, as we all know that. GATE is more of numericals. So you don't find much theory questions. But a little theory also required to understand the concept, so that you can remember forever. Okay. Again, special preparation is not required. You can prepare along with me. This preparation is more than sufficient. This practice is more than sufficient in this course. So you can score maximum in this course. That much I can assure you. 100% I can assure you. The last month I taught you EE class. doubly class also, whatever we covered in the regular session, that is more than sufficient. You don't require any special training again. So whatever numericals we worked out, that you prepare, maximum you can score. Here also, this much I can assure you. Okay then, again we'll meet tomorrow. So tomorrow I'll take two sessions. One session is 11 a.m. to 1 p.m. first session. I'll continue precipitation because so many varieties of problems are there in precipitation. Second session, so I'll try to complete precipitation and start the second session topic also. Tomorrow we'll announce. Well in advance we'll announce. Am I confusing you? Unacademy is offering discount 23% flat discount on the eve of New Year. Special discount flat on all subscriptions. And those who are writing 2023 GATE exam, they can enroll for a free mock exam. So use code GATE Civil. So they will disclose you all India rank also to take up the exam. So that may give you fair idea where exactly you stand in the competition, so that you can fine tune your preparation before you go into actual exam. This is important. Mock exams are important. So got some installments also. Thank you. We'll meet tomorrow again.